In this video, I will go through question 4 from exercise 10F mechanics 1. Two particles A and B of masses of 5 kg and 3 kg respectively are connected by a light inextensible string. Particle A lies on a rough horizontal table and the string passes over a small pulley which is fixed at the edge of the table. Particle B hangs freely. The friction between A and the table is 24.5 Newton. The system is released from the rest. Find A, the acceleration of the system, B, the tension in the string, and C, the magnitude of the force exerted on the pulley by the string. Okay, so first of all, I've done the diagram for the question. Okay. Right, here is the diagram and all the information about the particles. So 5 kg is here for A and 3 kg for B. Okay. So first of all, there should be mass times gravity in this direction, tension in this direction, another tension is in this direction based on Newton's third law, tension in this direction from A, another one in this direction. Okay, so there is a 24.5 newtons in this direction because it's friction force. So if the particle is moving in this direction, the friction should be in opposite direction. Reaction force should be upward because there is 5g Newton downward. Okay, so it's moving in this direction, therefore acceleration is in this direction, and the acceleration for this one is in this direction for A. Okay, so we wrote down all the information for both particles A and B and of course the pulley. For part A, to find out the acceleration, we need to apply the Newton's second law for both particles A and B. Okay, so for particle A, the forces are all horizontal. So it's moving in this direction, therefore T is positive, minus because 24.5 in opposite direction, therefore it is minus 24.5 is equal to mass times by acceleration. Okay, 5 times by acceleration, which we don't know what is acceleration yet. I call this one equation 1. We have nothing to do with reaction force on this 5g. Okay, because the particle is not moving vertically, so therefore acceleration vertically is equal to 0. For particle B, the forces are vertical and which is downward. It's positive. So therefore 3g minus t is equal to mass times by acceleration. Equation 2. This is simultaneous equation. Equation 1 plus equation 2 becomes t minus t is equal to 0. 3g minus 24.5. 3g minus 24.5 is equal to 5a plus 3a, which is 8a. So therefore a is equal to 3g minus 24.5 all over 8. Substituting 9.8 for g, we should be able to get 0.6125 meter per second squared. So therefore the acceleration of the system, is 0.6125 meter per second squared, which applies for the both particles A and B because the string is smooth. So, and the tension is the same for all of them. Part B, it says find the tension. To find the tension, obviously we worked out the acceleration. You can substitute the acceleration either into equation 1 or 2. So substituting A equals to 0.6125 in equation 1, okay, we should be able to get T minus 24.5 is equals to 5 times by 0.6125. T is equals to 27.5625. Yeah. The tension in the string is 27.6 Newton to 3 significant figures. So therefore the tension in the string is 27.6 Newton to 3 significant figures. Okay. The next part, which is quite easy and straightforward, it says the magnitude of the force exerted on the pulley by the string. So, first of all, we should see which forces are acting on pulley. Okay, there are only two forces acting on pulley. This T and this one. Okay, therefore, so there is T in this direction and T in this direction. We assume both of the T's are these two T's are making right angle triangle. So sum of these two forces is the force which is acting on the pulley. Okay. To find sum of these two forces, okay, we can use the vectors. Okay, so I draw this one here. So therefore, this is T. Sum of these two forces is the one which is starting from beginning of the first one and ends at end of the second one. Okay, so if this is 90 degrees, okay, it makes a square because both T's are the same. So this one would be 45 degrees, and similarly 45 and 90. Okay, so I call this one force F. By using Pythagoras, F squared is equal to T squared plus T squared. F squared is equals to 2T squared. f is equal to square root of 2t squared. So therefore f equals to t times by square root of 2. We know t is 27.5625. Therefore f is equal to 27.56 and so on. So enter exactly the same number into the calculator times by root 2. And finally f is equal to 38.979 Newton. And that's the end of the question 4.